physics lesson today. My name is Nicholas Okuthe. I want us to proceed with from where we left. We have already studied three types of radioactive radiations, that is alpha, beta, and gamma. And we have seen how they are produced. Now today we want to look at the properties of these three types of radiations. And we'll start with alpha particles. What are some of the properties that distinguish them from the others? Alpha, we have the properties listed down here. And the first property of alpha particle is that alpha is positively charged. Being positively charged, it means that when placed in a magnetic or electric field, it will be deflected. And of course, we know from the basic law of electrostatics that like poles repel and like poles attract. So, alpha being positively charged, we know when you place it in an electric field, it will be attracted towards the negative plate. Second property is that it has low penetrating power. And that goes hand in hand with the high ionization effect. The penetrating power relies so much on the energy. And because these particles are heavy and slow, they always have very low energy, and therefore they don't penetrate easily. Ionization is about knocking off of particles when they flow through air. So, because they have high, or they are heavy, they tend to hit air particles along their path, and that will make them have high ionization energy. Then they have short range in air. We have in the previous property here, they have heavy and slow. It means because they are slow, then they take time to move through air, and that makes them have short range in air. Then because of the low penetrating power, they are always easily stopped by a thin sheet of paper. So you just put a sheet of paper along their path, then the sheet of paper will be able to stop them. Finally, they affect photographic plates. They normally cause darkening of those photographic plates, something we call photographic emulsion. Yeah. Secondly, we look at beta particles. The properties of beta particles are almost opposite of what we have in alpha particles. One of them is that they are lighter. Alpha particles are heavy, but beta particles will now be lighter than the alpha particles. Then, beta particles are negatively charged. That also tells us that when placed in a magnetic field or electric field, they will be deflected. And of course, beta particles will now be deflected towards the positive plate. We look at the third property. They have more penetrating power than alpha particles. That means they have more energy than alpha. Then they have lower ionization effect, meaning they move through air very fast and are able to be knocked off by air particles because they are lighter. Being lighter, it means air particles can easily knock them off their path. So that will make them have lower ionization effect. Then they can penetrate thin sheet of paper, but are only stopped by aluminium foil. So when you put aluminium foil along the path, aluminium foil will stop them. Finally, we look at gamma rays. Gamma rays are not particles, but according to what we studied in the electromagnetic spectrum, you look at gamma rays. Gamma rays probably is the one with the highest frequency, and therefore they will have higher energy. In fact, among the three, they have the highest energy. So it is a high energy radiation. Then because there are no particles, then they have no mass. Yeah. Finally, or the third one here, they have no charge. Meaning when you place them in a magnetic or electric field, they are not going to be deflected. They will always travel in a straight line. And of course, those are one of the properties we studied in electromagnetic waves. Properties of electromagnetic wave, they always travel in a straight line. So whenever you place them in a magnetic or electric field, there will be no effect. Then they have high penetrating power, and that is because they have high energy. Low ionization effect, meaning they cannot be easily stopped by particles. They cannot knock off particles easily. Then they can penetrate thin sheet of paper. They can penetrate aluminium foil. but when you put thick block of lead or lead block along the path, then they will be absorbed or stopped. Now, with that, we can now do the summary of penetration of these radiations and also the effects on electric and magnetic field. So in terms of penetration power, alpha particle will travel, but when they reach a thin sheet of paper, they will get stopped or absorbed in that manner. What about beta? Beta particles will travel, but when they find a sheet of paper along their path, they won't stop, they will penetrate that, but the moment they reach aluminum foil, then aluminum foil will be able to stop them. What about gamma? Gamma rays will penetrate thin sheet of paper, will penetrate aluminum foil, but when they reach lead block, a thick one, then they get stopped or they get absorbed. So this is how we can easily summarize the property. Now, one thing we are seeing is that the penetration power depends on the energy, and this penetration power is more of converse of what we have in the ionization. So the more energetic particles will always have lower ionization effect, but less energetic particles, those that have less penetrating power, will have more ionization effect. So according to this, it means that gamma radiations have higher energy compared to alpha. So in the order in which they are arranged, alpha, beta, and gamma, it means they are arranged in order of increasing energy, increasing penetration power, and decreasing ionization effect. Let's look at effect on the electric field. I've talked about alpha particle. Electric field, we only have two types of field. We have the positive and the negative charges, or plates in this case. So when you have a radioactive source, then the radiations are released and directed in between the positive and the negative plates. What happens? Alpha particles, being positively charged, will tend to deflect towards the negative plate, this one here, and you can see the path is coming back. They are deviating towards the negative plate because they are positively charged. So positive will be attracted towards the negative plate. What about beta particles? Beta particles are negatively charged. So when placed in a magnetic field, they will tend to be attracted towards the positive plate. And there you can see beta particles getting attracted towards that positive plate like that, or deviating towards that path. Then what about gamma radiation? Gamma radiation will not be affected by positive or negative plates. So instead it will travel in a straight line. And from that diagram, also look at the range from the source here to where this, compared to alpha, from the source here to this point, you see alpha is slightly longer. Yeah, alpha is slightly longer, and that's what we are talking about, having short range in air, because they are light, they are heavy, so because they are heavier than that. Let's look at effects on the magnetic field. Magnetic field, we can have two types of field. We have field into and out of. So in this case, we have field out, field into the paper, or into, so magnetic field that's coming or into the paper, flowing into the paper. So when you look at alpha particle, they tend to be deflected towards the left side, while beta particle is tending to be deflected towards the right hand side. And you look at that path, you are seeing alpha, this beta. Beta is deviating more compared to alpha. Yeah, when you look at that curve, you compare it with this curve, you realize that beta is curving more, deviating more compared to alpha. But then gamma radiation just travels in a straight line because it is not affected by this field. When you look at field out of the paper, represented by a dot, when the field is out of the paper, we normally represent it by a dot like that. Sometimes we have a dot and a circle, but it's just the same thing. Then you look at beta particles now getting deflected to the left, alpha particle getting deflected to the right of the source. But gamma radiation will just travel in a straight line. So with this, sometimes we are tested on a diagram, given a diagram, either these or this, or the ones we have looked up there. Then you are asked to identify the radiation of the particles. Yeah. So basically, those are some of the properties that we have for these radioactive radiations. Yeah. So they can help us know and identify them. Thank you. Let's meet during our next lesson.